yeah, let's try another one. Let's try another one. So let's use the reverse. And here's a part B. So let's try one more. So we know that hyperbolic cot squared x minus 1 is hyperbolic cosec squared x. Okay? So let's prove this identity also. So remember, step number 1, substitute the definitions into the identity. Step number 2, simplify both sides. If left hand side equals right hand side, your identity is proved. Okay? So here goes. Step number 1. We need to use a definition of hyperbolic cot. So hyperbolic cot has a definition, e to the x plus e to the minus x over e to the x minus e to the minus x. And we need to use a definition of hyperbolic cosec, that is 2 over, okay, e to the x minus e to the minus x. So we need to use these two definitions. Okay. Now, if I consider the left hand side, so let's call this step 2. So replacing into both sides. So if I consider the left hand side, okay, so this term over here, hyperbolic cot squared x minus 1. So if I do the replacement, I'll get hyperbolic cot, which is e to the x plus e to the minus x over e to the x minus e to the minus x squared. Okay, so that's hyperbolic cot squared being replaced by its definition, minus the 1, so don't forget the minus 1. And if we simplify that, let's see what we have. Okay, so if we simplify that, we're going to have e to the x plus e to the minus x squared over e to the x minus e to the minus x squared minus 1. Okay, so in some cases you don't need to expand fully the whole thing. Okay, so let me show you a quick way. Yeah, so what I'm going to do is I'm going to take a common denominator of e to the x minus e to the minus x squared. So I'm going to have e to the x plus e to the minus x squared minus e to the x minus e to the minus x squared on top. Okay, and I'm not going to expand the denominator, I'm just going to expand the numerator. Okay, so let's see what we have as a result. So if I expand the first term here, I'll have e to the 2x plus 2 plus e to the minus 2x, okay, minus, I like to keep the terms in brackets to avoid making mistakes. So for the second term, I'll have e to the x minus 2 plus e to the minus 2x, everything divided by, okay, e to the x minus e to the minus x squared. Okay, so this should be a 2 here. Okay, now let's do some cancellations. So the e to the 2x and the minus e to the 2x, these two just will go. Okay, also the e to the minus 2x and the minus e to the minus 2x will go. So what are we left over? We're left over 2 minus 2 in the numerator, which is 4, over e to the x minus e to the minus x squared. So this is what you should have on the left hand side. Okay, so again, you don't need to expand out every single bracket. I left the denominator as it is. Okay, you can expand it. I mean, the method works. So the idea is to see whether the left and the right hand side equate. Okay, so you can expand it if you want, but I avoided that. So what I'm going to do is I'll do the same with the right hand side. So I'm going to use a definition on the right hand side, hoping to get the same term on the right. Okay, so we should get it 100%. So if we consider the right hand side, let's have a look. So the right hand side being hyperbolic cosec squared x. So if we use that definition, so here is our definition there. So if I do replacement, I've got 2 over e to the x minus e to the minus x squared. Okay, and as you can see, 2 squared, 4 over, and then we leave it as e to the x minus e to the minus x squared. Okay, and there you go. Left hand side equates to right hand side, so you proved your identity. So since left hand side is equal to the right hand side, okay, so therefore hyperbolic cot squared x minus 1 is indeed hyperbolic cosec squared x. So that's proven. Okay, so these are the steps. I hope you found this video helpful. Okay, so do related questions, so practice with related questions, and I hope to see you in the next video. Thank you.